Okay, so this is a 10E question number 9. A car of mass 900 kilograms pulls a trailer of mass 300 kilograms along a straight horizontal road using a light tow bar, which is parallel to the road. The horizontal resistance to the motion of the car and the trailer have magnitudes 200 newtons and 100 newtons respectively. The engine of the car produces a constant horizontal driving force of magnitude 1200 newtons. Show that the acceleration of the car and trailer are 0.75 meters per second squared. Okay, so let's read it again and then sketch it. So we've got a car and we've got a trailer. The car has mass 900 kilograms and the trailer has mass 300 kilograms, and they're connected by a light tow bar, so that means they're going to have some tensions in there and there, and they're going to have, so car and trailer have resistances of 200 and 100, so 200 there and 100 there, and driving force of the car is 1200, so it's going to be accelerating this way, but we don't know what acceleration is this time, and you can put some reactions in. So to find the acceleration of the whole system, so both the car and the trailer, we should treat it as one particle. So that one particle is going to have a forward force of 1200 newtons. It's going to have a weight of 1200 g. It's going to have a reaction, just net reaction. The two t's are going to cancel. That's the benefit of treating it as one particle, and you can do that because they're both moving in the same direction. And backwards we're going to have 100 newtons and 200 newtons, and it's accelerating forward to the right at a meters per second squared. So in part A, just do it over here underneath this diagram, let's find the resultant to the right, and that's going to be 1200 newtons minus 200 newtons minus 100 newtons, and that's our net force going to the right. 1200 going forwards and 100 and 200 going backwards, so they subtract them, and that's equal to mass. The whole mass is 1200 times the acceleration, so that gives us 900 equals 1200 A, and so A comes out as 0.75 meters per second squared. So we've shown what we needed to show. Part B then says find the tension, find the magnitude of the tension in the tow bar. And in order to do this, we look at each individual particle. So just pick one of the particles. I'm going to pick the trailer. Trailer's got tension going forward. It's got a reaction on the trailer. Backwards 100 and a weight of 300 g. And now we know that the acceleration is 0.75. So let's take the resultant going to the right. That's just the tension in the tow bar. Take away 100 because that's going to the left, and that's equal to mass times acceleration. And so the tension in the tow bar, 300 times 0.75 is 225, plus 100 is 325 newtons. So we found the tension in the tow bar. Just have a read of part C. So it says the car is moving along the road when the driver sees a set of traffic lights have turned red. He reduces the force produced by the engine to 0 and applies the brakes. Okay, so the forward force that used to be 1200 newtons has now gone to 0, and there's actually now a backward force applied from the brakes. The brakes produce a force on the car of magnitude F newtons, and the car and trailer decelerate. Given that the resistances to motion are unchanged and the magnitude of the thrust in the tow bar is 100, important that this is now a thrust. Okay, in the tow bar is 100. Find the value of F. So let's redraw this diagram. So we've still got trailer, car. Their weights are the same, and their reactions are still going to be there. Oh, 300G, not 30G. And they said that the resistances have remained the same, so that's still 100 here, and that's still 200 going here. And there's no forward force, right? So there was a brakes applied, and so there's going to be an F going to the left, which is slowing the whole thing down. And then it also said there was a thrust in the tow bar. Now thrust is a pushing force, okay, and this generally happens when a car brakes, like in this example, or a car is slowing down, and so this causes a pushing effect. The trailer pushes into the car, and the car pushes back into the trailer. So that's why we have these pushing forces. And we were told that the thrust was 100 newtons. We also know that it was decelerating. So if it's decelerating, then you can have the acceleration going to the left or to the right. Now I've put it to the right, just I put it to the right, but now I should be aware at this stage that because I've put my acceleration to the right, it's going to come out as negative because it's decelerating. If you put the acceleration going to the left, then you would have got a positive value. You still get the same answer. It's okay. It doesn't matter which way around you do it. Okay, so we've got two unknowns. We've got an F unknown and we've got an A as unknown. So I'm going to say let's have a look at the trailer first. The trailer doesn't have an F acting on it. It's going to have only acceleration as unknown. So let's look at the trailer. It's got 100 newtons going this way, 100 newtons going this way. Weight of 300 G. Reaction on the trailer, and then acceleration. So as you can see from this diagram, if we resolve to the right, then we're going to have only A as unknown. We've got 100 newtons going to the left caused by the tow bar, that's the thrust. So because it's going to the left, I'm going to put that as minus 100. And then you've got the resistance 100, which is also going to the left, so that's going to be another takeaway, 100 there. And that's equal to mass, which is 300, times the acceleration. And so we got minus 200 is equal to 300A, and so A is equal to minus 2/3. And as I said, I need to be aware that my acceleration was going to come out negative, which it did, which is a good thing. It's a good sign. Right, so we've got our acceleration. Now, remember the objective was to find out what F was. So let's look at the car. So the car has a weight of 900 G and had a reaction force there, and had an acceleration of minus 2/3, which we just found. Had brakes, which was slowing it down, resistance force of 200, but it had a forward force of 100, which was the thrust pushing, the trailer pushing into the car. So let's resolve going to the right. We've got hundreds going to the right and 100 going to the right. Got F going to the left, so that's going to be negative, and 200 going to the left also, so that's going to be negative 200. And that's equal to mass times acceleration, which was minus 2/3. And so if we work that out, on the left hand side we get minus F minus 100 is equal to minus 600. Let's move the F to the right hand side and bring the 600 to the left hand side, and so we get F is equal to 500 newtons, which is what the answer was. Okay, great.